Bismillahirrahmanirrahim. Assalamu alaikum wa rahmatullahi wa barakatuh. Now we are going to start the lecture 14. The title of this lecture is Course Outline Ring Synthesis. We have discussed two lectures, rings, cyclization reactions, and detailed granulation, three-membered rings included epoxide and cyclopropanes. Now we are going to discuss four-membered rings in which cyclic ethers, cyclic amines, and cyclobutenes, three type of four-membered rings, as well as five-membered rings. This is the lecture 14. Four-membered rings and five-membered rings will be discussed. First, we will discuss example of three-member ring in we have discussed in the previous lecture, but this is the example of three-member ring cyclopropane. Uh, this is the retrosynthesis, this connection approach FGI. The carbonyl group is converted into hydroxyl group by reduction and cleavage of two bonds. This is the cleavage of cyclopropane, alkene, and this is the carbene. And again, the function FGI, the OH is converted into carbonyl group by oxidation. So now the synthesis, this is alpha beta unsaturated carbonyl compound. By reduction in presence of lithium aluminum tetrahydride, it is converted into a hydroxyl group. Then in presence of diiodomethane copper zinc, the carbene react with this double bond form cyclopropane, and by the oxidation chromium oxide, OH is converted into carbonyl group. Another example of three-membered ring, it is substituted halide, substituted three-membered ring. Two bromides are attached with the cyclopropane. Uh, the disconnection approach, uh, two disconnection approach in which cyclopropane ring is disconnected, double bond, and this is the tribromo methane. Yes, this is ketal formations, just like the acetal or ketal formation, ketonic group, and diol. The diol is converted into ester. This is the synthesis. The diesters in presence of base and uh, methyl iodide because this alpha hydrogen is acidic in presence of base, uh, anion will be obtained. This react this anion or nucleophile react with methyl iodide, and two methyl iodide, two hydrogens are removed and two methyls will be added. Now, by the reduction in presence of lithium aluminum tetrahydride, the two astatic groups are reduced into a hydroxyl group. The next is this alpha beta unsaturated carbonyl compound react with this diol and acetal formation. This acetal formation, the double bond is here. The double bond is the double bond react with tribromomethane in presence of sodium hydroxide. Uh, the cyclopropane ring, substituted cyclopropane ring is obtained. This is your target molecule. This is the reaction in between tribromomethane and alkene in presence of basic medium. The base abstract proton, the carbene will be obtained. This carbene reacts with this alkene and the bromide will be removed and substituted dibromocyclopropane ring. This is now we start four-member rings disconnection approach as well as its synthesis. Cyclic ether. One CO bond is disconnected to produce hydroxy ketone. This is the example. Target molecule, cyclic ether, methoxy, and phenyl groups are attached. Disconnection. One CO bond is disconnected. Then we will obtain this intermediate and hydroxycarbonyl, and this is further and methoxy group, and further disconnected formaldehyde and carbonyl compound. This is the synthesis. We start from this reagent reaction react it reacts with formaldehyde and potassium carbonate as a base. The base abstract proton, alpha proton, and this nucleophile attack on this carbonyl, then hydroxyl group will be obtained. The reaction with tosyl chloride, the hydroxyl group will be replaced with tosyl group. This is a good leaving group, and this methoxy group react with this carbonyl and result the tosyl group will be removed and four-membered ring cyclic ethyl is obtained. The another four-membered ring cyclic amine. Two CN bonds are disconnected to give 1,3-dibromide. Two CN bonds. So 1,3-dibromide will be obtained, and this is secondary. This is primary amine synthesis. Uh, this is the electron react with this bromine, that phosphorus and ethyl alcohol. We will obtain this 1,3-dibromide ester. React with the primary amine. In result, we will obtain the target molecule. This nitrogen as a nucleophile react with this attack on this carbon, which is a good leaving group. It is a good leaving group, yes. And then nitrogen, and then after that nitrogen attack with this carbon, it is a good leaving group. So two hydrogens are replaced with, and the nitrogen attached with two carbons. Cyclobutane, two carbon-carbon bond are disconnected to give two alkenes like this. The synthesis is 2 plus 2 addition, and 4 member ring will be obtained. 5 member rings due to less ring strain, the cyclization of 5 member rings easier than 3 and 4 member rings. 5 member ring containing a heteroatom suggested that both carbon heterobonds are disconnected. Example, this is two bonds are disconnected. We will obtain this X means oxygen, nitrogen, and sulfur, and by the FGI, they will be OH. Synthesis to hydroxyl group. The compound react with phosphorus trichloride. The hydroxyl group replaced with two chloride groups, and the reaction with sodium halide. X means oxygen, nitrogen, sulfur, because the both chlorides are good leaving group. So this heteroatom react with this carbon, and the chloride will be removed. This hydroatom again react with this carbon, and another chloride will be removed. Then we will obtain our target molecule. Another example of five-member ring, two hydrogens are present. Uh, these carbon-nitrogen bond and carbon-nitrogen bonds are disconnected, and carbonyl and ethoxy group will be obtained, and the hydrazine will be removed. In synthesis, hydrazine reacts with this carbon and in result OH is formed and in the amylose step removal of water molecule, a double bond will be obtained, then nitrogen lone pair attack on this carbon, and a toxic group is good leaving group, so ethyl alcohol will be removed and we will obtain our target molecule. So this is the lecture. Uh, this is the lecture. Any question related to this lecture? Okay.